Hi class, today we're going to begin our discussion on chapter 5.3, Polynomial Functions. This will be page 1 of the notes. We'll start with the standardized test practice problem, and it reads, the volume of a box is given by the expression x cubed plus 3x squared minus x minus 3. The height of the box is given by the expression x minus 1. Find an expression for the area of the base of the box. So remember that volume is area of the base times the height. So what we're going to do is divide the volume by the height to get the area of the base. So we're going to use synthetic division. Remember that this is our divisor. But what we do is we set it equal to 0 and solve for x. So we add 1, add 1. So we're going to use x is 1 as our divisor. Our powers go in descending order, 3, 2, 1, 0. So we write our coefficients, 1, 3, negative 1, negative 3, and we put our 1 out front. We draw our line, or our arrow, draw the line under the arrow, and bring the 1 under the line. Multiply, 1 times 1 is 1, add 3 and 1, which is 4, multiply 1 and 4, which is 4, add negative 1 and 4, which is 3, multiply 1 and 3, which is 3, and add negative 3 and 3, which is 0. Bring the powers down by 1, so this would be x squared plus 4x plus 3 is the expression for the area of the base, and it looks like that would be choice A. Okay, so we're going to first of all talk about the degree of a polynomial. The degree of the polynomial is the greatest exponent of its variable. If the polynomial contains more than one variable, we must first find the sum on each term's exponents. Thus, the degree of a polynomial in more than one variable is the highest degree of any term of the polynomial. The lead coefficient of any polynomial is the coefficient on the term with the highest degree. So what that means mathematically is you look at your polynomial. You see that the highest power in it is a 4. So it is a degree 4, and the coefficient of the term that has that highest power is 3. So the lead coefficient is 3. On B, you can see that our highest power is 4 again. And the lead coefficient this time is negative 1. Now, if you have a variable or a polynomial with more than one variable, as in example C, then you take the sum of the powers on each term. So in other words, that of course would be squared, or 2, power 2. This is power 2. But this one is power 4 because you add the 2 and the 2. So this is actually a degree 4 with a lead coefficient of negative 3. On the next one, this is a 1 and 7 would be an 8. 2, 4, 5 would be a 9. And of course this one's an 8. So this is degree 9. With the lead coefficient of negative 3. So that's how you determine the degree and the lead coefficient of a polynomial. Okay, a polynomial function is a continuous function that can be described by a polynomial equation in one variable. If you know any element in the domain that would be the x value, an x value. If you know any element in the domain of any polynomial function, you can find the corresponding value in the range. So for example, we're going to find f of 2 and f of negative 5 for the function f of x equals 4x cubed minus 3x squared plus 2x minus 1. F of 2 means we're going to replace the x in the polynomial with the x's with 2, and we're going to simplify, and that's going to give you our value of the range. If the domain is x, or if the domain is 2 or x is 2, what is y or what is f of x? So we would rewrite this as 4 parenthesis 2 cubed minus 3 parenthesis 2 squared plus 2 parenthesis 2 minus 1. And we would simplify. 4 times 8, because 2 to the third power is 8, minus 3 times 4, because 2 squared is 4, plus 2 times 2, which is 4, minus 1. 4 times 8 would be 32. Then we would have minus 12. So let's kind of keep up as we go. That would be 20. Plus 4 would be 24. Minus 1 would be 23. Okay, on the second one, we're going to replace the x with a negative 5. So 4 parenthesis negative 5 cubed minus 3 parenthesis negative 5 squared plus 2 parenthesis negative 5 minus 1. All right, so this would be 4 times negative 125, because negative 5 to the third power is negative 125. Then we would have minus 3 times 25. We're squaring the negative 5 here, so that gives us 25. Then we would have minus 10 minus 1. Okay, so 4 times negative 125 is going to be negative 500, I believe. Yes, negative 500 minus 75, so that'd be negative 575, minus 10 would be negative 585, minus 1 would be negative 586. So in our domain, when the domain was negative 5, the range was negative 586. When the domain was 2, the range was 23. Now, on the last few examples, what we're going to do is we're going to pick the function that we're looking for. So we've got if p of x is 4x squared minus 3, and r of x is 1 plus 3x, find each value. So what you do is, first of all, look at what function you're working with. We're working with r, and we're going to replace the x's with 2a. So what I'm going to do is I'm going to write this function, but I'm going to take out the x here, and in parentheses I'm going to put a 2a. So I'm going to have 1 plus 3 times 2a, and then I just want to simplify that. So that would be 1 plus 6 a. Okay, on our next one, we have -4 times p of a. So we're going to take the function p, we're going to multiply the whole thing by -4, so I'm going to put a -4 out front, and then in the function, wherever there's an x, I'm going to replace it with an a. So I'm going to have 4 times a squared minus 3. So I'll have -4 times 4a squared minus 3. And I just want to distribute. -4 times 4a squared would be -16a squared. And -4 times -3 would be plus 12. So -16a squared plus 12. Okay, on the next one, r of x plus 2 means, I'm going to use this r function, and where x is, I'm going to replace that with a parenthesis containing x plus 2. So this would be 1 plus 3 times x plus 2. I want to simplify 1 plus 3x plus 6, because I distributed, and then I can add the 1 and the 6, so I'm going to have 3x plus 7. Okay, and then on our last one, finally, what we're going to do is we're going to use the p function, and we're going to replace the x, just the x, with an a squared. So it will look like this: 4 parenthesis a squared squared, because there's a squared out here, minus 3. So this would be 4a to the 4th minus 3. Notice I don't square the 4 because it's not grouped in the parentheses. I'm just squaring what's going in here for x. So a squared squared, you take your 2 times 2 to get your 4. So 4a to the 4th minus 3. Okay, that's all on page 1 of section 5.3. I'll see y'all next time for page 2. And in the meantime, I hope y'all have a great day.